I'm going to be talking about getting weird with Python and .NET. Mainly, this talk is going to be presenting a new tool that I will hopefully be releasing in the near future. I won't be releasing it right after this talk, unfortunately, just because it needs some polish. But and possibly integrating into Silent Trinity itself, which Jorge mentioned in his previous talk. But we're going to be talking about embedding Python interpreters, and which Python and IronPython interpreters, both of them this time, and we'll talk about that later in a second. And we'll talk about .NET and why, with this simple one trick, you'll make a lot of EDR vendors really, really hate you, just because of the somewhat lack of controls in place when it comes to dynamic scripting languages with .NET. I'll also be looking up the questions on Discord. So while I'm talking, please feel free to put your questions in there, because this is definitely a subject which might cause some confusion if you've never dealt with it before. So definitely feel free to ask as many questions as you want. I'll try to answer them as best as I can. So who am I? I am Marcello. I've been your MC for the past day. I go by Bike Leader on the Twitters. I work for Black Hills InfoSec. I'm mainly an offensive engineer / red teamer. I've created a bunch of open source tools over the past a long time. I've been doing this for as long as I remember, to be honest. And I've spoken at places. I do co-teach SANS classes.
Hey, Marcello.
Yeah, sure.
Hey, you want to press F5 to full screen that?
Oh, yep. Let me see if I can do that, because it wasn't. Okay, hold on one second.
Or if not, never mind.
That worked? No, that's even worse, I think.
No. All right, never mind.
Yeah, sorry about that. Let's see if I can. 1 second. Well, hopefully it's big enough. If not, let's do this. There you go. There you go. Is everyone able to see that?
It still looks the same as before. I wouldn't worry about it. Just
never mind.
You're good.
Okay, sorry about that. Yeah, I've been having a lot of GoToWebinar issues recently. So this is the agenda we're going to be talking about. We're going to be talking about the motivation and background. We're going to be talking about embedding interpreters and engines. I'm going to be talking briefly about Silent Trinity, which Jorge mentioned previously. And we're then going to be going into Python for .NET, which is the main tool that we're going to be using for the new tool that I'm going to be releasing, the main library that I'm going to be using for the main tool. And because of that discussion, we're also going to be talking about things that you may or may not know about Python. And we're going to be talking about the tool itself, which I've called Jormungandr, which is a giant snake in Norse mythology, if you're curious about that. And then we're going to be talking about detection and then Q&A. And are people screen freezing at who am I slide? I think you might need to refresh your browser.
No, you are stuck.
Oh, I am stuck? Oh, okay.
Yeah.
That's weird. Let me do something real quick. Leave it to the last presentation to screw everything up.
I know, I was going to say, everything went pretty smooth. All right, you're not present anymore. You're in motivation and background.
Okay, perfect. So I guess it was GoToWebinar this time. Okay, so I just restarted the screen sharing. So hopefully that fixes things. All golden. Okay, perfect. Awesome. So the main motivation for this is since the death of Empire, we've sort of been transitioning to C# tooling. Now, this is all great and dandy, but I'm going to be skipping through a lot of these initial slides just because it's just a lot of this stuff is basic, but at the same time, you sort of need it to understand the core concepts that we're going to be talking about. So Empire came along and sort of created this awesome C2 framework with PowerShell. PowerShell sort of went and died with all the defenses that Microsoft was putting in place recently, like strip block logging, AMSI, and all that good stuff. And mainly how PowerShell worked was you get a callback, so you execute some sort of code on the victim endpoint, you get a callback, right? And then you get a shell in Empire. And all tasks in Empire are basically just PowerShell source code, right? So PowerShell source code gets sent down, gets dynamically evaluated, and then the task result gets sent back to the C2 server. Perfect. And this was fantastic for a number of reasons, mainly because PowerShell was sort of like the holy grail of offensive tradecraft. It was a scripting language that was installed by default on Windows machines and allowed for completely in-memory execution of whatever you decide to execute on the target endpoint. But the main reason why PowerShell was awesome from a tradecraft standpoint was access to .NET APIs. So because PowerShell is a .NET language, it automatically has access to .NET. And this allows us to do a whole bunch of things because .NET is obviously tightly integrated with the Windows operating system. So you can basically monitor people's clipboards, you can keylog, you can inject shellcode because you can access Win32 APIs through .NET interop stuff, right? So from a tradecraft standpoint, this is basically the holy grail in terms of like what you would want out of a post-exploitation agent, right? But obviously, Microsoft started introducing defenses into this because people started using it all over the place. APT actors, pen testers. So we needed a way of defending against this stuff. And Microsoft, over the course of 3-4 years, started introducing a whole bunch of controls into the PowerShell runtime, including AMSI, script block logging, constrained language mode, and these severely cut down on the amount of PowerShell scripts that you can execute in some environments, or some clients, like some clients that we have at Black Hills, like they have PowerShell completely locked down to a point where logging is enabled. So if you use PowerShell at all, you'll probably get caught immediately, right? So how do we start to get around some of these defenses? Well, we can start patching AMSI, which is the actual technology which basically signatures off bad mullet PowerShell scripts. We can also perform obfuscation, but the problem is obfuscation really it can get complicated with certain long PowerShell scripts. It might not work that well, and plus obfuscation when it comes to pen tests and red teams isn't ideal for a number of reasons, including attribution and all that stuff. So I personally, this is just a personal opinion, I really don't like obfuscating anything, just because it just adds a whole lot of more work on top of things. But we also started patching AMSI. The problem is you sort of have to patch AMSI before AMSI kicked in, and you have to make your AMSI bypasses not signature on AMSI. So it was this whole chicken and egg problem, and that was really weird to use. Or you could just use the PowerShell v2 runtime, which is still installed on the majority of customers that I come across, amazingly enough. The PowerShell v2 runtime won't have any of these defenses. So if a client or if anyone has PowerShell v2 installed in your environment, which by default, if you upgrade Windows 10, you will have, then you can just bypass all these defenses and you're good to go there from an offensive perspective. So the immediate solution from the red teaming community was to migrate to CSharp, because the CSharp runtime had access to the same .NET APIs as PowerShell did, and none of the controls were in place. So it was basically PowerShell all over again, only in a different language, right? And this was what caused the great tooling migration, I've called it, of 2017, 2018, where we started seeing PowerSploit become SharpView. We started seeing all of these tools that pen testers worked with being ported over to C#. But the biggest issue with this was that C# is a compiled language, okay? Well, at least the issue that I had with it was that it was a compiled language. And what that means is that it adds a whole, lot of overhead in terms of actually getting your tools and operation capabilities with CI/CD pipelines to a point where you can actually perform operations. And if you don't have that set up and you're a small pen testing company, that kind of thing, like it can be hard to actually use some of this tradecraft without automation, right? So my question really was, is there a way of going back to throwing source code around, right? And that's what led me to this whole rabbit hole of trying to embed interpreters. But Covenant came along and tried to solve some of this issue by dynamically compiling stuff server-side. So the way Covenant works is that instead of throwing source code around, now we're throwing compiled C# binaries around. So we execute some code on the victim endpoint, you get a callback to Covenant. Covenant dynamically compiles modules or payloads or whatever you want to execute on the victim endpoint server side, and it sends down the compiled C# binary. Now, this gets rid of some of that, some of the issue with overhead, but the problem is there is a lot of overhead in terms of code to actually get that compilation server side to work. And there's a whole other host of issues alongside of that. But it's not exactly the ideal solution. It also makes things less flexible. So if you have to develop modules on the fly, then yeah, that's not exactly the most ideal solution in terms of that, right? So my real issue was that all of this stuff really does give a lot more overhead and setup in terms of CI/CD pipelines, boilerplate code, and it's not exactly trivial to compile. I don't know if you tried doing this with like the Roslyn API, but if you tried compiling C# dynamically, it's not exactly the most ideal and easy thing to do, especially if you're talking about .NET Framework and .NET Core interop, trying to get like .NET Core to compile .NET Framework compatible code. It's a whole mess of stuff that you have to do. So like I said before, I wanted to go back to using a scripting language because it just made things so much easier, right? You don't have to compile stuff. You can write modules on the fly because everything's dynamic. It gets dynamically evaluated on the endpoint. But the main issue that I had was I didn't want it to be PowerShell, right? I don't want to use PowerShell because PowerShell has all those defenses in place in order that we need to bypass. So there really, at the time when I started diving into this, there were only two options. There was JScript and VBScript. They're both provided by default using this, provided by the Windows Script host environment on Windows. However, on newer Windows 10 builds, these two are subject to AMSI and a whole other host of defenses. And they cannot, and also the main issue is that by default, at least, they cannot access .NET APIs. You can work around that using weird, archaic Windows technologies and really complicated serialization stuff like .NET to JS and that kind of thing. But out of the box, it does not provide access to .NET APIs directly, right? So I really needed something in .NET, which is why I decided to see if there is a way of executing other languages within .NET, the .NET runtime. And it turns out, yes, there are a lot of ways of doing that. And actually doing that is not as difficult as what you may think, because the .NET framework was built to do exactly this, right? And this leads me to my definition of .NET, because if you go to the Microsoft website and just like if you've never done .NET development before and try to understand what the .NET actually is, you'll get confused pretty fast, as I did, because unless you already have some .NET development background, because all of the definitions on Stack Overflow and the Microsoft documentation assume that you've already programmed in .NET before and know a lot of the .NET terminology, right? So this is my humble definition of .NET for people who have never coded in .NET before, which is .NET is a language independent development platform comprised of a set of tools, infrastructure, and libraries that enables you to create cross-platform applications, okay? Now, the key part of that sentence is .NET is a language independent development environment, okay? Because C# is not .NET. What people tend to associate C# with .NET, but it really isn't. .NET is just a set of tools that enables you to create programming languages to interact with it. And that is very important concept to understand, especially for what I'm about to talk next, because now we're going to be talking about .NET languages. As I said before, .NET is just a platform to create languages, right? So people have done exactly that, both officially supported languages by Microsoft and third-party community developers as well. So there's officially supported languages like C#, which is the de facto language used to communicate with the framework. There's PowerShell. PowerShell is a .NET language. It's a scripting language. There's also F#. I've not played around with F# actually. I find its syntax very unappealing. But F# is also a .NET, officially supported .NET scripting language by Microsoft. I've not yet played around with it. But then there's also IronPython. There's also boolang. I don't know how many people have heard of boolang before, but boolang is amazing, and it's what Silent Trinity uses as its agent language, which we'll talk about a bit. There's also IronRuby. There's a bunch of others. Now that I've went down this rabbit hole, I keep finding them every other day or so, and they're amazing. But the key takeaway from this is that all of these languages are interoperable with one another because they're built on the same framework. They're all built on .NET framework. So what that means is that what you can do in C#, you can do in boolang, right? What you can do in IronPython, you can do in IronRuby, PowerShell, F#. They're all built on the same framework, meaning that they're all interoperable with each other, which allows you to pull off some really cool stuff. And the best part about it is boolang, IronRuby, and IronPython specifically, they are scripting languages, right? And they don't have any of the defenses that PowerShell has in place, with the exception of a few edge cases, because now Microsoft has started implementing some of those defenses in the underlying .NET framework. But because of how these languages work, those defenses really don't have a lot to go on. And if we have time, I can answer a little bit more questions about those as well. So now we're going to be talking about interpreters and engines, and hopefully up to this point, embedding interpreters and engines. Hopefully up to this point, this has somewhat made sense, and because now things are going to get a little bit weird because we're going to be taking these concepts and sort of mashing them all together. Okay, so because they're all interoperable, you can do the same stuff as you can do in PowerShell with IronPython. And IronPython was the first .NET scripting language that I've tried. So IronPython is a .NET implementation of the Python programming language on top of .NET. Okay, so it's not normal Python. Normal Python is based in C, right? IronPython is based entirely in the .NET framework. So everything it does communicates directly to the .NET framework. And I tried experimenting with this, and originally the Silent Trinity agent was actually written in IronPython. But the main issue with IronPython is that unfortunately it doesn't support DLL import attributes. And DLL import attributes is what allows you to call underlying non.NET Win32 APIs. So these are all the APIs that allow you to inject shellcode, to allow you to monitor the clipboard, to keylog, and all that stuff. You need to call these APIs outside of .NET in order to do stuff that we need on a red team, right? So unfortunately, that had that limitation. And you can find all of some of this code that I'm going to be talking about on this repository here, offensive DLR, on my GitHub page. And this is going to have a lot of these POCs that I'm going to be talking about, specifically in this particular instance, Sharp Snake and Invoke IronPython. These two are examples of embedding the IronPython engine within C#. Sharp Snake, that is. Sharp Snake embeds IronPython into C#, and Invoke IronPython embeds the IronPython runtime within PowerShell. So with these, you're able to execute Python, at least IronPython, not normal Python, through PowerShell or C#. Okay, hopefully that all makes sense. And IronPython. So the biggest issue with a lot of these is that, sorry about that. We'll go back to the slide. The biggest issue with a lot of these languages is that these, they're obviously not installed by default. So what that means is that they require some DLLs in order to be present, in order to actually spin up their engines and actually execute code. In IronPython's case, you're going to need 4. The IronPython modules DLL, and then scripting and Microsoft Dynamic. These are 4 DLLs that you're going to be needing in order to actually run IronPython code. Okay. Now, these are .NET assemblies, and unfortunately, I'm not going to be getting into too much about what a .NET assembly is. But suffice it to say that a .NET assembly can be a DLL and an executable. Okay, and these can be injected into completely injected into memory filelessly. So you can reflectively inject these DLLs and executables into memory without any issues whatsoever, and that's fully supported by .NET. One of .NET's use cases is actually doing this. Now, just because it has the DLL and .exe extension does not mean that it's a standard executable. The format of a .NET assembly is actually completely different from what you'd expect from a normal executable or a DLL. So suffice it to say, these four modules can be, these four DLLs can be completely injected into memory through PowerShell or C# or whatever .NET language you choose, because again, they're all interoperable with each other, right? So now, so from on the repository, you can find those two examples. I'm not going to be demoing it because it's not that fun, to be honest. It's just executing like a print statement in IronPython. And also, I want to actually get to the meat of this talk, which is the new stuff. So I'm going to jump ahead and go straight to boolang, because boolang is amazing. Boolang is a love child between Python and C#. So if you're familiar with both Python and C#, you're going to feel very at home here, because it's like a combination of the two. It's heavily inspired by Python, which is fantastic because I'm a sort of a Python guy. But the greatest thing is that it can call native functions. So it can do that DLL import statement that IronPython couldn't, and it's supported natively. So what that means is that we can do, like, we can call mini dump write dump, which allows you to dump LSAS memory directly through .NET, right? And this example, and this is what, like 16 lines of code counting white spaces. It's available on that GitHub repo that I mentioned previously if you want to take a look at this. But in this 16 lines of code, we're just calling the mini dump write dump API, and we're dumping the LSAS memory to disk, okay? And this is just fully supported. You can run this code snippet through a boolang interpreter embedded in PowerShell, and examples of this are on that repository that I mentioned before, which is offensive DLR. Okay, so you can all find these all this code you can find offensive DLR. These are just, it's a toolbox of all of this stuff that I've been working on recently. And there are also two examples there called runBoo and Invoke JumpScare. The latter I thought was cute because, you know, boo and stuff. But runBoo gives you an example of embedding the boolang compiler within a C# binary, and Invoke JumpScare in PowerShell. So same thing, right? Boolang requires 3 .NET assemblies, which is great, which is far less than IronPython. And we can just call assembly.load on them and load them directly into memory, and we're all good to go there. And this is what Silent Trinity is based off of. Silent Trinity uses boolang in order to actually run code on the remote system dynamically through an embedded boolang compiler in some .NET language. So it can be PowerShell, it can be C#, it can be really anything that's installed by default on Windows that can interact with .NET. Okay, and that really is the power of Silent Trinity, comes from that dynamic execution. ClearScript is another discovery, which I'll talk about briefly. ClearScript is essentially a way of executing JScript and VBScript through C# without going through the native implementations. It always uses the Windows script host environment, but it uses its own way of interacting with Windows script host. But the great thing about using ClearScript is that you can actually expose the .NET CLR to JScript and VBScript. So remember I talked about before that JScript and VBScript couldn't execute .NET runtimes, .NET APIs. If you use JScript through the ClearScript engine, you can. And that brings a whole new level of stuff that you can do with JScript and VBScript, okay? And great thing about ClearScript, it's an official Microsoft project. It was actually made to do exactly this, to add scripting to your .NET applications, which is absolutely amazing. So now with ClearScript, you can do stuff like this. So this is a little C# proof of concept, which executes JScript within ClearScript's engine, right, which is embedded in a C# binary. Now I know that's a mouthful, but hopefully the code snippet makes it a lot more simpler to understand. And again, this is also available on that offensive DLR repository that I mentioned earlier. In the form of Invoke ClearScript. So Invoke ClearScript is exactly this. So it embeds the ClearScript engine within PowerShell, right? And then executes some JScript or VBScript And the great thing about this is that, again, you can call .NET APIs from JScript this way. You can actually expose .NET to JScript. And if you're interested in more about this, I did a talk at DerpCon, which actually demos some of these examples. So if you're interested in like seeing demos of these, you can take a look at that DerpCon talk from last year and take a look and see them in action. I'm just going to jump ahead because this isn't, well, this is all the background that you need in order to understand what's coming. Also, this slide, which I think is super useful, they're .NET Alchemy recipes. So the more I delved into this, the more of these languages I found. And there are some insane .NET languages out there that do some crazy stuff. So there's Lua.NET implementation. So for some reason, if you wanted to call .NET APIs or write your post-exploitation scripts in Lua, you can do that. That's not a problem. There's also .NET WebAssembly, which is just absolutely crazy. That allows you to execute WebAssemblies, dynamically create and execute WebAssemblies within memory in .NET. So that, as a red teamer and a pen tester, that hopefully has set off some alarm bells, because that allows you to do some pretty crazy stuff in terms of like possibly hosting a website written in WebAssembly that just looks like a legitimate website if you visit it, but if you pull it down with a specific agent, you can actually execute malicious code. Your wheels start turning there in terms of like potential offensive capabilities. I have yet to try that, but it's some crazy stuff, and I'm probably going to need to learn a lot more about WebAssembly in order to actually tackle that. There's ClearScript that I talk about. There's also IronPython 2. IronPython 3 is in the works, which implements the Python runtime for the Python 3 runtime, that is, for C# for .NET. And then there's Iron Ruby and boolang, which I've talked about already. But if you want, you can just directly try Silent Trinity. So Silent Trinity wraps a lot of these concepts that I've just talked about in a nice little ribbon, and it allows you to deploy a fully functioning post-exploitation C2 agent that uses the boolang interpreter. But the great thing about Silent Trinity is that it's all dynamic again. So it's going back to the days of PowerShell, where you just host source code server-side, send it down to the endpoint, and that gets dynamically compiled on the endpoint and executed. Okay, so what that means is that you can dynamically write modules server-side, and it's all source code, so you can just edit them with Visual Studio, no binaries, nothing like that. So from an operational standpoint, it makes things a lot easier, in my opinion. And also, it's somewhat of a weird take on a C2 tool, which I kind of like weird stuff, as you probably noticed by now. So I personally like the idea of just using, like, embedding these languages. And on a side note, you can actually embed multiple languages within one another. So if you wanted to embed IronPython within boolang, within PowerShell, within C#, you can totally do that, and it'll just work. You might run into a couple of problems, like towards the third or fourth language, just because of all the assemblies that every one of those engines need. I'm speaking out of experience here, because I've tried like the most amount of languages you can embed, and it goes around three to four, and then you start having a bit of problems just trying to resolve the required assemblies needed. But let's jump to the main stage of this talk, the main point of this talk, which is Python for .NET. And this is what I've been trying to work with recently, because I think it's a really cool take on this whole on this whole concept. So Python for .NET is a GitHub open source project, and it basically allows you to call normal Python, it allows you to call .NET APIs seamlessly from a normal Python installation. Okay, so let that sink in for a second. So remember IronPython? IronPython was a specific version of Python written for .NET. Okay, so what that means is that's like, while most things with Python will work with IronPython, it's not completely compatible. Python for .NET, on the other hand, takes just normal bog standard Python, so written in C, and gives it an interface to .NET. So what this means is that with a normal Python installation on Windows, you can literally just do pip install python.net and automatically start calling .NET APIs through your normal Python interpreter, which you grab from python.org. Okay, so, and this is an important distinction here, is that Python .NET is not a .NET language. It's just an interface to it. Okay, so it just literally gives you a seamless integration to .NET in order to call its APIs. Okay, and that's what I'm going to be demoing here in a second, and it's going to be a live demo. So fingers crossed on that one. I'm all about the YOLO life if you haven't got this already. So Python for .NET. Another great thing about Python for .NET is that you can embed it, obviously. So what that means is that you can take a C# binary, embed Python for .NET, and if you have a Python installation, normal Python installation on your Windows computer, Windows laptop, you'll be able to just automatically call .NET APIs to Python and execute Python code. And I love this little take from the Python.NET homepage, which is embedding Python. Note, because Python code running under Python for .NET is inherently unverifiable, it runs totally under the radar of the security infrastructure, the CLR. So yeah, that's pretty much exactly what I want. So yeah, I took this, I tried working with it, and that's when I came up with your Mungander. Okay, I can't even pronounce it correctly, and I named it. So you can think of this tool, what I'm going to be demoing in a second, as sort of like a mini Python installer, and that doesn't sound all cool and all, but when I demo it, hopefully things will start clicking, because it's just a C# binary. Okay, so it's just a little executable that you run, and it'll automatically install Python using an embedded installer, which we'll talk about in a second. You don't necessarily have to pack the Python installation with the binary itself. You can get rid of that and actually have it download Python automatically at runtime from python.org. Okay, so you run the C# binary. If you don't give it automatically pack it with the installation, Python installation itself, it'll just go out and download python.org, download Python from python.org. Okay, because of the way the Python interpreter works, the normal Python interpreter, you will not be able to load Python within memory without modifying the actual Python interpreter itself, which, I mean, I would like to do that actually, but the problem is it would just take a lot more time. And for demonstration purposes, it's probably easier to understand this way as well. So currently what this does is, once it gets that Python installation somehow, it'll unzip it to local app data, and that's it, done. You can now call .NET APIs from normal Python, okay? And this has a lot of interesting implications, because what this also means is that you can install Python libraries, so normal Python libraries, think Impacket, for example, hint, hint, from your C2 server. So if once this is integrated into Silent Trinity, what this means is that you'll be able to issue commands to your agent that automatically goes out, installs Impacket, and you can run whatever script from Impacket you want on the actual endpoint, okay? And on top of that, you can call .NET APIs. So what that means is that you can inject shellcode. You can monitor keystrokes. You can do whatever you want. You can do all the stuff that we can do in PowerShell, only using regular Python written in C. Because again, Python for .NET just provides you that interface in order to actually access the .NET API, okay? And yeah, so with some extra work, you can actually get this to install packages with pip. I currently don't have that working, unfortunately, and this is what I mean with some extra polish, but I will demonstrate it to you just to give you an idea of what I'm talking about here. So let's run over to that real quick. I'm gonna switch over to my handy dandy VM here. And I'm gonna make this a whole lot bigger for you. Let's see, let's make this huge. Let's make this 36. This is gonna be, there you go, that works. And let's take this Visual Studio Code right here and make this 200, perfect. So hopefully you all see that. Hopefully that's pretty big. So that should settle that. So this is the actual code that does all that, okay? So we have, this is the main C# binary, which will take care of everything for you. It actually install Python if it's not already packaged with it from python.org using the embedded installation, which is something worth talking about actually before I go directly into this. Let me open up a browser here, because if you're not aware, Python provides a number of installations, okay? So not just the regular, especially for Windows, not just the regular Python installation. If we go to downloads here, all releases, we go to other, oh no, not other, sorry about that, Windows, and then we go all the way down, all the way down, all the way down, oh maybe not, hold on, let's see. Embeddable zip file, okay? So let me see if I can make this bigger. There you go. So you can see that for Windows, it provides a bunch of installations, including something called a web-based installer or an embeddable zip file. Okay, I don't know if anybody has actually taken the time to actually go out and see what that is, but the name is pretty self-explanatory. What that means is that you'll be able to basically create a portable Python installation by using this embeddable zip file. So what this is just a zip file, right? That contains all of the precompiled standard library for Python. And it makes it so that it's portable. So you just download the zip file and there's no installation whatsoever. And you can just run Python directly using the contents of the zip file, okay? Which is perfect this is exactly what we want. So Python actually provides this for you on every Python release. So we're taking advantage of that in the actual CSharp program and saying, hey, if I don't package the Python installation for you, because say I wanted to install additional libraries along with Python and just embed that directly in the zip file, just go download it from python.org. And also from a TTP detection standpoint, python.org is probably much less suspicious than custom evil domain at companyname.com, right? So it's also a lot stealthier this way as well if you really want to do it this way, okay? So let's take a look at this for a second. I'm going to open up another Explorer window here, and I'm going to go to app data, local temp. So this is the Python installation which it downloaded previously. So I'm just going to delete that real quick. There you go. So that's deleted. So now this is going to be just a complete clean run of this tool, right? So let's start this up. Oh my God, that is big. Okay, wait 1 second. Let me just see if I can expand this because the path is, nope. Okay, so I'm going to make this smaller then, just because otherwise you won't see anything. Hopefully 24 will work. Yeah, that's much better. Okay, perfect. Ah, yes, much better. Okay, so we're running the executable here. Again, this is a .NET assembly, so you can just inject this directly into memory if you want to, or load this with Covenant or whatever you want. Okay, so let's back up because it did a lot of things at the same time here. So it first loaded the Python runtime.dll. So this DLL.NET assembly is what is the magic sauce behind Python.NET, okay? So this DLL contains all of the code necessary for normal Python to interact with the .NET framework, okay? And because we need this at runtime, we need to somehow resolve that. This tool does a little trickery using some hooks in .NET to actually resolve that DLL at runtime, okay? Then it creates two GUIDs, one tracking the installation ID, because what happens if we run multiple agents on the same host? There's no reason to re-download Python again. We can just reuse the same installation, right? It detected automatically that we didn't package Python with the binary, so it actually went out, automatically downloaded Python from python.org. It checked that the hashes matched, so that the hashes on the Python installation hashes actually checked out with the downloaded version, and then extracted that zip file, right, to app data local temp. Okay, so this is all of the files that come, and they're very few, as you've noticed, because Python pulls some trickery when it comes to this, and if I have time, I can explain that a bit. It just automatically decompresses them and puts them into app data local temp, and it drops us, for demonstration purposes, I did this, and it drops us into an interpreter. Now we're able to actually execute Python code. So if I do import OS, right, os.system, which just executes a shell command, you see that we're actually calling Python, right? But this is the kicker, because we're calling we're executing Python from a C# binary loaded with python.net, I can execute .NET APIs, which is amazing. So now I can do stuff like import CLR. So CLR, now I have access to .NET. I can then do from system import console, right? Which, or just how about import system? How about that? Import system. Oh yeah, because I have to spell. Spelling works. System.console. Hello from .NET in Python DerpCon 2020, and you've obviously seen how bad of a typer I am. And nope, because I'm still having some typos, because yep, I am that bad of a typer. Nope. We'll get here, I swear. What did I do this time? Let's try that again. Oh yeah, because yeah, demoing code live is not good. System from system import console. There you go. And it helps if I do the actual call, console.write line. You start coding in these languages long enough, you start mixing them all up, and your brain becomes just a gelatin mess. And there you go. So now we're able to call .NET from Python. Okay, so now if I wanted to write any kind of .NET code that interacts with the clipboard or anything that would require a whole slew of libraries written in C in order to interact with, but I don't need those anymore. I can just go through .NET, and I can also, if I wanted to, execute PowerShell from this, or really anything that a .NET runtime allows you to do. Okay, and what's fantastic about, at least in my mind, what's great about downloading the Python installation from actual GitHub, from the python.org website itself, is that it already sort of does a lot of the work for you. Ooh, sorry about that. In the sense that it comes already installed with all of the site packages, the built-in Python system packages already precompiled. So in terms of space, it's minimized, so it's optimized as much as possible. And it pulls some trickery with a PTH file. So if you're not familiar with Python PTH file, PTH files allow you to specify where to actually, well, it allows you to tell Python where to actually go and grab the Python system packages, okay? So in this particular case, we're telling Python, hey, take a look in the current directory for a python37.zip. Because if you don't know, Python actually allows you to read Python files from a zip file automatically. It's the equivalent of like a jar file in Java. The zip files in Python are the same thing, and there are actually libraries out there that allow you to package executables using this technique as well. And specifically in the zip file, we're telling Python, hey, I want you to take a look at the site packages folder within the zip file in order to actually find the standard library, okay? And then we're telling it to import site, which does a couple other things in order to make this a little bit more seamless. So you can start thinking about this from an offensive perspective as well, right? It makes the wheels turn a bit, that you can actually specify UNC paths for this. If you wanted to, you could load the Python standard library from a UNC path, for example, on an SMB server hosted on the network, which would make things a little bit more stealthy in terms of less stuff on disk and that kind of thing. You can also specify the Python DLL, so the actual in the code here, when it goes to actually load the Python runtime itself, we're setting a bunch of environment variables which tells Python.net, hey, I want you to go and grab the Python installation from this location on disk. But again, it's Windows, so UNC paths works as much as path on disk. So we can tell Python, we can tell this C# program, hey, I want you to grab the Python installation from a remote UNC path, okay? And again, the difference between this and going through IronPython is that this is completely compatible with normal Python libraries. So you can, again, like you can call impacket from this. You can see here I had embedded some code in here to test out using pip to actually dynamically install libraries at runtime, and then actually just interact with them. So I'm trying to get pip work in order to actually download like Python libraries at runtime. And a question from SAR: it installs Python in a temp directory. If you continue to import libraries, etc., does it also store them on disk? Correct. Yes, it does also store them on disk. That's a limitation with just how Python works. If you want to, which I'm considering doing just because of this, you can actually go out and modify the Python interpreter itself to actually load these all from memory, which would take a decent amount of time, but it would be worth it in order to do this. But yeah, they do load them from disk. And yes, UNC also means WebDAV with SSL, so there is that as well. That's also another thing to check out, and allows for some interesting shenanigans with that. Okay, so using this method, you can actually dynamically load normal Python libraries within CSharp and call .NET APIs, which I think in terms of tradecraft is pretty amazing, just because it provides you a whole lot of flexibility in terms of like what you can do with a C2 agent that's built using this. And the idea is that this would get integrated into Silent Trinity, so that you'd have an option of a host of different languages. So say you wanted to have a Python-based agent, so you can execute post-exploitation scripts in Python. You can do that as well. You can have a boolang agent. You can have IronPython agent. The idea of Silent Trinity is eventually going to be to collect all of these languages into a single C2 tool, so that you can choose which language to write your post-exploitation scripts in, if that makes sense. So yeah, that is a quick demo of that. And again, like the end goal here is going to be to integrate this into Silent Trinity so that it's all wrapped up in a nice little ribbon, as I like saying, for you to use, so that you don't have to deal with any of this and it just works, right? And again, like this paragraph right here. So this goes through is inherently unverifiable. So everything is dynamic, the way it executes those .NET APIs. And you can also execute assemblies directly through Python this way as well. So say you wanted to run SharpHound or Rubius, or really any of the C# tools that have come out recently, you can just load them directly with Python for .NET, and it just works because, again, it's an interface to the CLR through Python. And it also allows you to do some interesting post-exploitation stuff in terms of actually executing these through a already present CPython installation, especially since Windows Store has now has the ability of installing Python. So sometimes I see endpoints with Python directly installed. You can just pip install python.net and execute all your C# post-exploitation stuff that way. So it allows for a lot of flexibility. So detection. Detection is hard when it comes to this stuff. It is getting better, very slowly better. We're in the same situation as we were with PowerShell 4 or 5 years ago. That being said, unfortunately, a lot of these detections when it comes to these kind of languages are not very effective just because of their dynamic nature. And this is where I sort of get into the argument sort of get into the mindset of possibly suggesting to Microsoft that they should implement some kind of controls to limit the embedding of dynamic languages, because that just bypasses a lot of these security mechanisms that they're putting in place. Like the introduction to AMSI into the underlying .NET framework is a good step forward. ETW logging is a good step forward. But the thing is, it really isn't scalable nor effective when it comes to dynamic languages. And additionally, since both of those detections, both of those mechanisms run in user space, you can just patch those out. in one way or another. And you can, again, do that through Python.net or boolang or whatever language you choose to embed, right? So in terms of detections, it's not exactly where it should be. But again, it's catching up. And I definitely assume that in like 3 or 4 years, we'll have better controls in place for this. But I personally think that there should be some more controls in terms of this ability to embed dynamic languages within .NET itself. So, like I said before, .NET 4.8 has AMSI integration, and there's also a question from the chat. So the question is, how detectable is all this, and what would you look for if it's trying to detect it? Those embedded Python zip installs. Correct. In terms of the way I've implemented this tool currently, you would detect it based on a Python install in the temp directory. Now, the thing is, Python installations, they're not exactly, they're somewhat common, right? So you would have to really, really sort of filter out the signal to noise ratio, especially if you're trying to detect stuff in like a development environment or any type of network operations center, right? You would have to really filter those signals down in order to actually properly detect that. So it's not, it really depends on the environment you're doing. So yes, so currently the way to detect this would be some kind of Python installation in the temp directory. How feasible that is, it really depends on I guess your environment. Let me just check real quick if there's any questions from GoToWebinar. Let's see.
No, there hasn't been any.
Okay, awesome, perfect. But there's, okay, so going back to the detections, the .NET 4.8 has AMSI integration, so that's definitely a step forward. There's also ETW, which is basically a low-level logging mechanism to give you analytics and metrics into .NET processes, which are running on a machine. The problem is there really isn't a good way, at least a scalable way of actually aggregating those logs. That might change in the future. It's probably going to change very soon. But the tools that Microsoft provides you to actually build these detections using ETW are very much a do-it-yourself sort of deal, where they provide you a library and you're expected to build a tool off of that library, right? And I'm talking specifically about Crab's ETW here. I do believe there is some integration with ETW with the Sysmon that I've yet to look into. So I personally wouldn't have a lot I wouldn't have a lot of knowledge around that. There's a host of open source tools though that allows you to sort of at least ingest these events from ETW. There's Silk ETW, there's Module Monitor. There's also a bunch of other talks that try to actually implement some of those logging mechanisms within a tool that is somewhat easy to use in an enterprise environment. But it's open source. And in corporate environments, that may or may not be a possibility. But again, like from just a plain old detection point of view, your regular off-the-shelf malware that uses this, including Silent Trinity, does not do any ETW hooking or ETW patching or AMSI patching for you automatically for good reason, because, you know, I mean, I do want to not just destroy the world. But it does not patch any ETW whatsoever. So if you load the Silent Trinity boolang agent as of right now, you'll see that a bunch of the boolang compilers and IronPython compilers are loaded into memory. And you can get these logs via ETW. But again, ETW is also user space, so you can just patch that out, and this list would just disappear completely. So there's that too. So that's something to take in mind. And with that, that ends the talk. Are there any questions from Discord or GoToWebinar?
Yeah, you have at least one in webinar.
Okay. Let's see if I can pull that out.
Yeah, David asked, couldn't you mitigate this by requiring 2FA to open PowerShell?
I am not aware that you are able to do that. It is possible that some tool allows you to do that. But the thing is, so PowerShell isn't the only way you can execute this, right? Because you can just execute this from any .NET language. So It doesn't necessarily have to be PowerShell. So it can be MS build, for example. MS build, there's research out there that allows you to execute C# binaries using MS build or lulbins on the system itself. So really anything on the operating system, Windows operating system that is built in .NET could technically execute this stuff. It's not only PowerShell. Locking down PowerShell is still recommended, very much so. Just because you can bypass it with this does not mean that you shouldn't do that. We also have a question from Discord. Could you load Python using the standard Boo engine delivery method in ST? So a weird conga of boo python.net. Correct. Yes, you could. You could load the boolang compiler from within python.net from a C# binary. Yes, that is completely possible. My brain hurts just thinking about it. I don't know why you'd want to do that, because once you're, I guess, in one of these languages, doesn't really matter. But yes, you could technically do that. Have you used any of this in an engagement or anything real world or just POC only? No, I have used Silent Trinity specifically on multiple engagements. It has bypassed a lot of high-end EDR solutions. It varies wildly though, because if you tune the EDR solutions correctly, it could possibly detect this in one way or another. That being said, I'm not exactly sure on the status of ETW integration with EDR solutions. I think most of them just started supporting AMSI, so I doubt that a lot of them have any sort of ETW logging capabilities. If there is syslog monitoring for alerting on PowerShell commands, would this be detected? No, because like I said, PowerShell is not the only way to load this. You can load this through anything that talks to .NET. So lulbins, MS build, it can be an executable. It can be anything that just talks with .NET. It could technically load this. Anything that can ingest an assembly, .NET assembly can technically load this. Lots of scripting languages supported. No chance to see Golang integrated in the future. Well, unfortunately, so there are other C2 frameworks that do have Golang, like Merlin, and you can actually take a look at C2 matrix in order to figure out like which implant uses Golang. However, the idea behind Silent Trinity is using this weird embedding situation where, or at least using these languages embedded within one another in order to evade and provide dynamic script execution, if that makes sense. With that being said, I think that's all the questions we have time for. I will be sticking around in the chat, obviously, so if you have any more questions, definitely let me know. And also, this is the end of the red team track. So thank you everyone for joining. Andre, I don't know if you have any announcements to make.
No, unfortunately, I was trying to find another prize to give out, but we definitely gave a ton of stuff throughout the entire con, and congrats to everyone who did get something. I know there are still some potential random drawings, but again, those are random. But actually, there will be end of conference services surveys, and if you fill that out, I know there is a prize for a random person. Don't know off the top of my head where that link is, but I'll try to get that. But yeah, no, we appreciate it. For those who don't know, we had over 2,500 people registered, and just from you guys, we had over 20 grand donated towards the COVID relief. So we want to thank you guys all again, all you guys for attending, all our sponsors, and yeah, we hope you had a great time, and hopefully next year we can see most of you guys in person.
Yeah, and also I just want to give a quick reminder that we do have t-shirts available, so feel free to grab that swag. And again, all this money goes to the COVID relief effort, so feel free to grab those t-shirts. I also would absolutely love, I think actually we might have reached 100 subscribers, because I think I saw a message about that, but if you could smash that subscribe button on our YouTube channel, that would be amazing, so that we can actually have a proper channel name instead of a long URL that's pretty impractical. And yeah, think that's it, everybody. Thank you so much for joining. Thank you, everyone, for the support. Hopefully, once all of this is over, we can do this physically in the near future, and I'm really looking forward to that. And but always the virtual side I would love to keep the virtual side personally too, because it allows this to be accessible to everyone around the world. So hopefully we'll do a combination of physical and virtual. All of this is recorded, so it'll be available on that YouTube channel. And remember to smash that subscribe button. And the slides will be available hopefully soon, and we'll be tweeting out the videos and the slides also. And with that, that is it, everybody. Thank you so much.
At this point, I mean, if you don't leave, we're just going to end the broadcast. So kick you guys out. But once again, thank you, and take care.